Bob, are you ready to take it away? Bob's in physics, and he's going to talk with us about using Graphical Analysis Pro in the classroom.
Okay, hi everybody. I'll share my screen. So in physics this year, we started teaching the freshman year physics in what's called workshop physics format. And what's happening there is the idea is students do collect data and try to figure out the physics of things through data analysis and discussion and notes from me as well. And so we're really trying to get them to be scientific and discover some ideas through data analysis. And so we bought a lot of vernier equipment, vernier sensors, in order to collect that data. They use sensors and so on to collect it. And so what I want to do is kind of go through the different ways you can look at data. I'll just do a quick little synopsis. And actually, in the fall, we started with graphical analysis. And then Vernier came out with the Graphical Analysis Pro in between semesters. And then since then, I've been looking at Graphical Analysis Pro, and I'll talk about that as well. So I'll start with the graphical analysis. And graphical analysis actually is a free download. And Graphical Analysis Pro has a cost. It's like $250 for 500 students for a one-year license. So, but the graphical analysis itself is free. And so if you look down at the bottom of my screen, you'll see this sine curve looking app, and I'll just click on that. And what I'm going to do is go to, I'm going to choose a file that's already set up here. You'll see that there's census data collection. Now, data sharing and manual entry. And I'm going to talk about the manual entry part first. If they're doing a lab, we can have them enter data. And I have a lab here called Part 1 Pressure. There it is. And so I'll open up the data table. And so what happened here is this is a pressure versus volume graph. And so they would be using equipment. In this case, there's not a sensor. Well, no, I take that back. There is a sensor, but they're entering the data on their own. This is manual entry. There's a volume on the x-axis, pressure on the y-axis. And on the bottom left-hand corner there, where you see that little graph-looking icon, you click on that, and they can do a curve fit. And this is an inverse relationship. So we see this curve fit, and we'll hit apply. And we'll get this equation here, y equals a over x. And so what we have to realize is that, it's pressure's on the y-axis. So it's really pressure equals, the A value is 516. So pressure equals 516 kilopascals, milliliters, all over the milliliters on the x-axis, or the volume on the x-axis. And so this way, they have this data, and there can be some leading questions that ask them about that data and so on. And one of the things you can do here is, Excel can do this too, but this is more user-friendly with the sensors. It connects directly with sensors and so on. But they do have a calculated column part here. Like if we wanted to linearize this graph, we can go to the volume column, hit on those three dots up at the top there, and I have different column options. I can add a manual column, but I'm going to add a calculated column. I want to do 1 over V. Oh, my lights in my office are off. Okay, I want to do 1 over volume. And so my units would be 1 over milliliters. And I'm just going to insert an expression for that. And there's a variety of different expressions. I'm going to pick the A over X here, and I'm going to hit apply. And I can now go to the x-axis and pick a different variable to work with. And I want to work with the 1 over V. And so now I have a linear graph. And so those are the kinds of things we can look at. And I'm going to apply a curve fit to that. and that's a linear graph, and I'll hit apply. And so I can look at the linear aspect of this data. So that's just one way of entering data. Another thing, if you collect sensor data, oh, actually, here's another interesting thing. Where's my beats? That's right, I want to do beats. So there's a sound sensor that we have, and we collect sound. And so what happens is we have two speakers at different frequencies. And I saw Mike with your instruments there. You know all about this, the beats, trying to get rid of beats when you tune your instruments. And so anyway, we can analyze beats. We have a sound sensor, and we can see the different beats. You get that wow, wow, wow noise. And so they can actually, look at that. They can click on it and say, okay, that's 0.0567 seconds, and the next beat's at 0.1546 seconds. And so they can analyze the sensor. So they're not inputting data here. They're just taking information from the sensor and analyzing that. In this case, they're just looking at the beat frequency, how many beats per second actually are occurring. I'm going to open up another one here, and the other one I want to look at is, where is it? Well, actually, let me go to this one. Acceleration of a car on a ramp. So this is where so let me just talk about this. So, I mean, it was kind of interesting. We had all these, you can do all these very interesting things with the graphs and so on. And there's a video on this one, and you can only do this with Graphical Analysis Pro. But actually, let me play this first. And you can see some data here on the left-hand side on the graph. And so that data is being fed directly in from a sensor. And so I'm not going to talk about the video aspect of this yet, because I still want to talk about the free version of graphical analysis. And so we have a position versus time graph, a velocity versus time graph, and I could come up here and tell it to look at 3 graphs, and it can also show the acceleration versus time graph. And the graphs are beautiful typically with these sensors. It really does a nice job. And so students can look at this data and clearly understand how the mathematics and the physics interconnect. And so, for example, what you can do is you can click on a graph, highlight it, and I can do that's a line right there, that part of the graph. And so I could do a curve fit. The curve fit's linear, so I hit apply. And what ends up happening is I get this equation here. And let me actually only go to one graph, because then it's easier to see what's going on with that. And I don't want the position versus time graph. I want to talk about the velocity versus time graph. So I just come over on the axis here and click on it. And so it's very intuitive. Whoa, where'd it go? So let me hit play. It should show up again, I guess. Whoa, where is it? I didn't tell it which data set to work with, data set 3. And so I'm going to highlight that, and I'm going to do a curve fit with that. It's going to be linear. I'm going to hit apply. And so it tells me there's an equation there, y equals mx plus b. We know the slope there is negative 1.279. The y-intercept is 1.953. And so what we have students do is take a look at, well, what's on the y-axis, what's on the x-axis, how does it fit into that equation, and what does this all mean? What's the physics concepts behind this? And we do some scaffolding to get there and so on, so they don't have to make these huge jumps, but that's the basic idea behind it. And I'm going to go to, so actually what ends up happening here is they should come away with a graph of velocity equals negative 1.279 meters per second squared. They're supposed to understand that that slopes the acceleration. Negative 1.279 meters per second squared times t. And so that really then leads into discussions about, well, what's the general equation for velocity and so on. So anyway, let me go to displacement versus time graph, because people who are calculus teachers may be interested in this. I can highlight this part of the graph. This is a parabolic graph. And I can do a curve fit on this, and I'll hit apply curve fit. And it's not linear. So what I do is I pick quadratic, I hit apply, and I get this parabola graph. And so it's, it's position equals, and then you can see the coefficient there and so on. What's interesting about this in calculus, if you take the derivative of this function, you should get the velocity function. And so you can directly connect that. You can have students take the derivative of that, go to your velocity graph, and see if those functions match. And it's typically close. It's it's not exactly perfect, but it's really close. It's a really great. It's a great piece of software. And so you can go. It's kind of nice. You can jump from one graph to the next. You can kind of these relationships really show up nicely. Before all this technology, I used to use stopwatches and meter sticks and so on, and the data just wasn't good enough to be able to do the kinds of things you can do here. All right, now, so that's the basic idea of graphical analysis. When Graphical Analysis Pro came about during the winter in between semesters, I was intrigued by it because during the fall semester, only one person in the group could really collect the data. There'd be one computer there collecting the data, and only one student had the data in front of them. Graphical Analysis Pro has a feature now where every person in the group can collect the data. The data can be shared amongst everyone, and so everyone is looking at the graph. So that's actually the reason why that's one of the reasons why I wanted to get Graphical Analysis Pro. The other reason is because remote students can also see this data through the Wi-Fi. Remote students receive these graphs, real-time graphs of these experiments. And so, people are on Zoom or they're FaceTiming and they're sharing graphs, through Wi-Fi. It really, I really like that feature a lot. And there's a last feature that I'm hopefully going to use that I've been working on. There's a little bit of a glitch in this feature, and I'll show you what I mean, but it's kind of a neat feature where you import the video like I'm showing you right here. And what you do is you sync it up with the graph. And so I'm going to I'll open up 3 graphs. We'll get all 3 motion graphs together. And I have to hit this arrow button up here. Whoops. And so then I'm going to click on this, like up in the left-hand corner, there's that movie script icon or whatever it's called. Well, actually, I've tried, what the problem here is that once you go out of the program, the syncing unsyncs itself. It's not quite synced up very well. And I'll show you what I mean by that. If I hit play here, you could see that the data started collecting before I actually pushed. Oh, and we have acceleration, velocity. I got to push this back to displace to position. Okay. So anyway, those are the 3 motion graphs, and you can see those are really nice graphs. But the problem here is that the video is not synced up again. So, but this actually does bring an opportunity for me to show you how to sync up the video. So I click on this little icon up in the left-hand corner, this button up here that says sync data with videos on. And what I do is I move my video up to a point where I know exactly what the graph should look like. I'll come up so that the cart is at the very top of its motion. And that's at 2.39 seconds. So I'm going to enter that in my video time, 2.39. And then my data time is going to be right at the very top there at 1.5 seconds. So I know at the top of that displacement versus time graph, or I could look at the velocity versus time graph. And where the velocity is 0, I know the cart will be at the very top. And so the data set, so what I'm doing right now is syncing up the data with the video. So the data is at 1.5 seconds, the video is at 2.39 seconds. And we should be in good shape here. Although my video, I'm not sure if that's going to be a problem. My video, let me put my video back to where I want it. Still learning this piece, but once I can get this to work, this is going to be really nice. I'm going to use this as a training video for future learning assistants and future professors. I'm going to have each lab like this, and the video, I can talk in the video and talk about what's going on so that people don't have to reinvent the wheel. I can have this set up and then have future instructors and future learning assistants kind of get an idea. Now, of course, they could teach it whatever way they want, but at least they don't have to reinvent the wheel every time. And then I can also save this as files. I can use this with remote students. I'm going to use it this summer with remote summer school students at Fisher. And so I really see some really good opportunities for this. I just have to kind of clear up a few things. So anyway, let me let's play this. And so you can see there that the moment the cart left my hand was about right there where you know, and it really did, you could see it really does sync up pretty good. I just got to make sure when I save it, it keeps synced up. So I think that's a good general overview of Graphical Analysis Pro and graphical analysis.
Thank you so much, Bob. You took
Sure.
me back to the last time I had physics, which was in high school.
Oh, nice.